Welcome to my plasma and a microwave video then. Warning, I am a trained lunatic. I will not be held accountable for any fires, explosions, blindness, toxic gas inhalation, bizarre mutations, or death that may occur as a result of you attempting this at home. Next up, some simple science. Skip ahead if you want to see the plasma. And warning, don't try this at home. Despite making up an estimated 99% of the visible universe, plasma, or ionized gas, is extremely misunderstood by most people. Plasma is rare on Earth, but you can see it in fluorescent light, TVs, plasma balls, plasma cutters, and the aurora borealis. Plasma is commonly known as the fourth state of matter, and I'll explain a little bit more about it soon, but first I'm going to run over some basic chemistry. So here you see the nucleus of an atom, which is composed of protons and neutrons, and circling around it are electrons. Electrons have to fall within certain orbits or shells. In the first orbit you can only have a maximum of 2 electrons, and in the second you can have a maximum of 8. Electrons are responsible for nearly all the chemistry we know, and these are very important in plasma itself. So here we see some basic atoms and a molecule. We have an oxygen atom, which is the 8th element. That's because it has 8 protons in the middle of it, and as you can see it has 8 electrons, 2 in the first shell and 6 in the second shell. It can have a maximum of 8, and molecules like to have complete orbits, complete shells. Then we have a hydrogen atom. This has 1 proton in the middle and 1 electron, therefore it can receive 1 extra electron in its outer shell. So here we have a water molecule. This is composed of 1 oxygen and 2 hydrogen. And this makes the atom stable because you then have 8 electrons in the outer shell here, and the outer shell of the hydrogen is also full because they've bonded. So moving on to show you the different states of matter now then. So this is a solid. Everything's nice and organised and regular, and the atoms stay completely stationary. If we add heat to the mix, it will turn into a liquid. You can see now that the atoms are moving around and bumping off of each other, and the electrons are still orbiting nicely around the nucleus, which has the protons and the neutrons. So you continue to add heat, the mixture expands, as you can see, and the molecules start to move faster and faster. Once it gets to a critical temperature, it then becomes a gas, where the molecules escape and are free to move around the complete volume which they're in. They're no longer stuck within a set volume. So if it continues to heat up, you can see that the electrons are still orbiting nicely around the protons, but the particles are moving faster and faster. Eventually, however, if it gets hot enough, the electrons completely escape the orbits, and that's what causes a plasma. It's the electrons falling back into the orbits of the nucleuses which cause the plasma to give off light. So moving on now to the plasma in a microwave experiment. You will need a microwave, a match, candle or toothpick will also do, a holder for the match, a lighter, a heat resistant clear bowl, supports to allow air to flow in and out of the bowl, a fire extinguisher, a well ventilated area, and balls of steel. Again, do not try this at home. So this is the setup you need. As you can see, the red and blue things are going to support the glass. This will allow a bit of air to get through so the candle doesn't go out too quickly, and also prop the glass up so that it doesn't heat up too quickly either. You've then got your candle in the middle, which provides the naked flame. Again, a toothpick or match will do as long as you can keep them lit well enough. And on top we have the glass, which is to contain the plasma. We've got a little setup. All that remains is to light the candle. Timer on. glass over the top, close the microwave, and eventually we should see some plasma. There we go. Shall I let it explode?